5.2.5 tells us that a machine part is assembled by fastening 2 components of type A and 3 components of type B end to end. Okay. The lengths of type A in millimeters are independent. They're normally distributed with a mean of 37 and a variance of 0.49. And B are independent. Again, notice it does tell us that they're independent because we only know how to add the variances of independent random variables. Okay. Tells us we want to add 2 of A and 3 of B, and we want to find the probability that the total is between 144 and 147. Okay, so one of the things I like to do first is take my normal notation and rewrite this. So this means the mu, or the mean, for A is 37, and the variance, I like to write as variance, so I remember it's variance and not standard deviation, is 0.49. And the mean for B is 24. The variance for B is 0.09. The second thing you need to do is completely ignore the notation the book uses in their solutions manual. They're trying to save space, and it is completely counterintuitive. This is what I always do. I always make a new random variable. So let's say T for my total length. I just pick T. Pick any letter you want. T is going to be equal to, we need 2 of A's, so A plus A, plus B, plus B, plus B. So that's our new random variable. So let's find the mean of T using our rules. Okay. So we know the expected value. This goes back to everything we learned in section 2.6. If we want the expected value of A plus A plus B plus B plus B, well, we can just add each expected value, right? So expected value of A plus expected value of A plus da da da. Okay, so let's see what that means. We're going to have to add 37 plus 37 plus 24 plus 24 plus 24, or 146. Okay, now we need to find the variance of T, because we don't know rules to find the standard deviation if we add them together, but we do for variance. So basically we want the variance of T, which is going to be the variance, again, of this A plus A plus B plus B plus B. So this is my process every time. Make the new random variable, find the new mean, find the new variance. Even though this is something we learned so long ago, these rules are very useful, and I write it out every time. So it'll be the variance of A plus the variance of A plus the variance of B, etc. Okay, so my variance, notice we were already given variance, not standard deviation, so I just have to do 0.49 plus 0.49 plus 0.09 plus 0.09 plus 0.09, which gives me 1.25. Because I'm looking for a probability, we know they're normally distributed. I know I'm going to have to find a z-value, and that requires a standard deviation. So let's take the square root of our variance. So the square root of 1.25 gives me 1.12. So that's my new mean, my new variance, my new standard deviation. Now I can find a z-value. So your z-value should be our t-value minus the mean of our t over the standard deviation of our t. Okay, so let's see. So the specific t-value I'm interested in, oh, there's 2 of them, so let's start with 144. So 144 minus the mean of 146 over the standard deviation of 1.12. Okay, so it looks like that z-value, I'll call it z1 because I had 2 of them, was negative 1.79. Now you might have also rounded that at negative 1.78. Either way, your answer should be close enough. You'll notice that the book, their answers are usually a bit different because they round differently. They don't use the table. They can just use the calculator. You're just trying to make sure your answers are close. Okay. My second z-value, we're going to do this other total value on it of 147 minus expected of 146 divided by the standard deviation of 1.12 gives me 0.89, so 0.89. Now I make sure I always draw a picture every time. So here is z equals negative 1.79. Here is z equals 0.89. Notice it's not to scale. That's okay. So now I know that I want to shade in the middle. It said what's the probability the total length is between these values. So I'm shading in the middle. I'm going to pull up my normal table. I'm looking for negative 1.79, so my negative 1.7, go to the 9. Looks like the area to the left of negative 1.79 is 0.0367. So this area from here to the left is 0.0367. Remember that, again, your table always gives you areas to the left, which makes it kind of complicated for this problem. So if we find from negative 1.79 over, and then we look at 0.89 and go all the way to the left, let's do that next. So we'll have to go to the next page. We're looking for 0.89. Looks like my area all the way left is 0.8133. This is 0.8133. So we have the area to the left of negative 1.79, the area to the left of 0.89, but we wanted the area in the middle. So if we subtract, it'll kind of cancel out this piece that we didn't want and just gives the area in the middle. So the probability that our total, or T, is between 144 and 147 is going to be equal to, we'll do 0.8133 minus 0.0367, which gives me 0.7766. Again, the textbook rounds differently. Well, they don't round, they use the calculator. So your answer should just be at least close. Again, they do really weird things, notations, because they're just trying to save so much space. This is the much better way to do it. Make a new random variable, find your mean of your new random variable, your variance, your standard deviation, and then just find a normal curve area.